At the end of class last time, we had defined the volume using cylindrical shells. So we did the height, radius, etc. And this is the part where we ended. And this was my idea for the motivation of integration by parts. If you look at the integral, we've got two terms. Before we get into that, why did I split the integral last time?
Two different methods.
There are two different methods, in a way, in that integral. One piece is just this method, the second piece, Walsh method, and then you put those together in cylindrical shells to find the volume. At the end of class, I said, well, we want to integrate and find the answer. So one function multiplied by another function. What is the usual thing that we go to anytime you have a function within a function or one function multiplied with another function? What method? U substitution. But unfortunately, we cannot use U substitution. Why? If I pick one term, one function as U, I've got to have the other part, yes? Well, if U, other part of the derivative of U, if I picked 8 minus x as U, does du over dx equal to ln of x plus 1? No, so no good. If I picked U as 8 minus x, am I going to get either of those? No. What about ln of x plus 1? If I pick U to be ln of x plus 1, what is du? What is the derivative of ln of x? 1 over x. Do I see 1 over x? No. X is hanging out right there. It's not in the denominator. So U substitution has failed us. So there has to be another way. So that's where techniques of integration comes into play. All of chapter 7 is on techniques. The first one is integration by parts. Okay, well, we already know we have two parts, correct? Parts simply means functions. There is a U part and there is a V part. Now, the standard approach is to have integral U dv. So the dv part is what's going to have the differential. In other words, whatever you pick as dv must include the variable that you're going to integrate with respect to. For instance, if I pick dv to be 8 minus x, then I must have 8 minus x times dx in dv. Good? So dv has to go with a dx term. And then you've got to pick u, which would be the leftover part. One might wonder, well, which is u, which is v? A way that works for the most part is I let. I love algebra, trigonometry, and eating. Easier way to remember. ILET. What does ILET stand for? So in math, log, algebraic, trigonometric, exponential. It sort of tells you the order in which you pick u and dv. So, if you have an integral that has an inverse trigonometry function, or an inverse trigonometric function, a logarithmic function, u will be the inverse function, dv will be the logarithmic function. If you have a trigonometric function and an exponential function, u would be the trigonometric function, e would be the dv. The exponential function will be dv. Good? So it sort of gives you an order in which you are going to pick u and dv with me. So ILATE is going to give you the order of picking u dv, and don't forget, dv must contain the differential. Even before we start though, if you paid attention way back when, one important tip that I gave you is parentheses. Always make sure to use them, yes? Second, anytime you have logarithms, I said you've got to try and do something. What is that something? You see a problem with logarithms, first thing that must come to your mind is it should be properties of logarithm. Do we remember multiplication property, addition property, the power rule property? Yes. So one might want to combine these two, but I won't recommend it. Why? What is ln of, say, A minus ln of B? Put a calculus from last semester.
Division.
Huh?
Division.
Division what, Jordan? If I stood here and I said ln x dx integral 2, 4, would that help you?
Definitely not helpful, right?
Right, so you've got to put it in words. So division, correct, dividing what then?
X plus 1 by 2x plus 3.
Very good, is that it? Do I simply write it as x plus 1 over 2x plus 3 after?
It's 2x minus 3.
Oh, it's 2x minus 3, okay. I thought you were going to give me the answer, but Jordan has helped us out. Caleb, then Alan. Caleb, you were about to say something. No? Alan?
I don't believe I raised my hand.
Oh, you didn't? Okay.
Wouldn't
Right,
it
why don't you like this?
be, wouldn't it be natural, parentheses, x plus 1 divided by 2x minus 3?
Okay, Jordan simply said it's x plus 1 over 2x minus 3. Forgot that ln part entirely. So you can write it as ln of x plus 1 divided by ln of 2x minus 3. But I will not do that in this problem. Good? Don't make that mistake. Sometimes it's going to make life easier. Sometimes it is going to make your life painful. Okay. Based on ILATE, I do have an algebraic part. I do have a logarithmic part. So which is which?
U would be the logarithm and then your algebraic expression.
So u would be the logarithm and
dv would be the a minus x.
dv would be the 8 minus x. Now, as I mentioned, I don't know if I did. Anytime you have inverse functions and logarithmic functions, ILATE could get really problematic. In other words, it might fail to work. Good. Now, based on ILATE, Caleb said, well, the logarithmic part will be u, so ln of x plus 1, and the algebraic part will be dv, 8 minus x dx. Perfectly fine. There is a trick with which I can get to the answer without iLate failing, but I don't want to get to that yet. So this is a case where iLate is going to sort of fail, unless you use the trick. We will deal with that later. So I'm going to reverse my order. So sometimes it's either iLate or it's IA L. Sometimes it is Liate. Good. Liate, I and L would switch. So iLate is a possibility. Liate is another possibility. Things do get complicated when you have to choose between, or when you have an integral that has inverse functions, logarithmic functions. Okay, well, I know from experience that U has to be 8 minus x, and dv has to be the remaining part ln. I want you to know the trick as well. If iLate fails directly without using any algebraic trick, this is what you've got to keep in your mind. The choice of U must be in such a way that as you differentiate, you eventually head towards 0. Good? So you start with U, you take the derivative once, you take the derivative the second time, eventually U, the derivative of U must become 0. Good? If it doesn't, you made a bad choice. Good? Let's see how iLate fails us. If I pick U to be ln of x plus 1, what is the first derivative of ln of x plus 1? Carter, you should know this. You gave me the correct answer for ln of x. And
I think it's 1 over x plus 1 squared. That's what I would say.
Carter, do you want to correct Caleb?
Should let other people talk.
Okay, in that
I
case,
did my one video.
done it? No. No, absolutely said no. Okay, Bryce? No. What's your name?
Noah,
Noah.
is it 1 over x plus 1?
Very good. Noah, see, you got the correct answer. It is 1 over x plus 1. Okay, I differentiate 1 over x plus 1 one more time. What will I get? Michael, number 1. Number 2. You know who's next. Michael, number 3. Don't know.
Or the x plus 1 for negative 2.
Very good, you're missing a negative. Negative 1 over x plus 1 squared, or negative x plus 1 raised negative 2. Okay, so you sort of see a pattern. So you start U ln of x plus 1, U prime 1 over x plus 1, U double prime negative 1 over x plus 1 squared, triple prime negative 2, positive 2 over x plus 1 cubed. Is that ever going to become 0? No. So if you follow iLate or Liate, it is not going to work. This is a case where it fails. Good? Can't do. So, erase. Major fail. Good. What if I picked 8 minus x as U? I haven't gotten to the formula yet. I'm still picking U and dv. First time I differentiate, what will I get? Take this. 4. What? Caleb?
-1,
-1. Next up,
0.
yes, gone. So I hit 0 right away. So the best choice, or the only good choice here, is 8 minus x. Yes, question?
So is I the order in which you choose u and dv?
Yes,
So you would choose the inverse function before you would choose the logarithm?
yes.
Okay. And
So
then
you would
you should
choose-
always at some point hit 0?
You'd always choose the algebraic before the trigonometry. So this part right here works, most part it will just work out. But the I and the L part, you can't trust. If you have trust issues, serious problem there, it will give you a panic attack. Good. So I have picked you. If I pick you, whatever that remains, which should become dv, and as I mentioned at the beginning, the dv must contain the differential. Good? Okay. U dv. Good. Once I've grabbed another color, I stole my pens. Someone is onto my game. I hit it in Sigma
Black one?
Oh, black one was worse, thank you. I picked the wrong pen. So this will help. U, dv, side note, the u's will go through differentiation at each step. dv will go through integration. So if you have to pursue multiple steps, you will go through differentiation successively. dv, on the other hand, we go through integration. Good? Easier way to remember dv, integrate, you get v. Good? Okay. What is the formula? Standard u v minus integral v d. Good. That is standard, and there is a reason why it is the way it is. Be honest, go for this class. If you want to know, you can stop by during office hours. We have picked u to be 8 minus x. dv is that. Okay. Good. You are going to take the derivative of u with respect to x because u has to go through differentiation. So du over dx. We know the derivative, it is -1. Rewrite, if du over dx is -1, what is du? Dx or negative dx. Negative dx. Okay, good. The other part is dv. Naturally, you've got to integrate. Do we know the integral of ln of x? Okay. Do we know the integral?
Yes.
So integral of ln of x is x, ln of x minus 1. Right? If you took the derivative of that, you will get ln of x. Without the negative 1, you won't get the derivative. But if it's differential equation or a course like that, you can just add it to a constant. But we need that negative 1. Okay. Using the same logic, here it is a simple u substitution. So I'm going to write it this way. I don't want to confuse, I'll leave it as is. So u substitution in this case, if you pick u to be x plus 1, du would be dx. That will go back to what Xavier said. The integrating, v goes for integration, u goes through differentiation. I would end up getting x plus 1 times ln of x plus 1 minus 1. Good? Yes, no, maybe? That is the side note that I wanted to write. This is the formula that you need to know. This is also, this is in that sheet that I provided. So we take the derivative of 8 minus x cutter.
So we're supposed to add this to the sheet, or is that already on the sheet?
Yeah, add that to the sheet.
Okay.
It's missing, so make sure you put that in there. I mean, if you want to add other stuff to that sheet, go for it. I don't want.
Does that count as our cheat sheet?
No, you get another one.
Okay, so we get formula sheet and a cheat sheet.
So I expect you all to do well with all the cheat sheet. I didn't get any of that when I was in school. Don't ask me when. So derivative, integral. Now u v, which is 8 minus x times x plus 1 times ln of x plus 1 minus 1. Good. Minus integral v x plus 1 times ln of x plus 1. What is du? V du, but minus dx. Good. So all I'm doing is plugging it back into the formula. So uv minus integral v and du.
Are you missing the minus 1 for the integral? After ln x plus 1?
Oh, here?
Yeah.
Yeah, thanks. Minus. How about that? I got my black. I know I did change the ink. I was losing my mind. Okay, the first part doesn't have integrals in it, correct? Yes. So we can just apply the limit. Well, lower limit is 0, upper limit is 2. If you apply the limit, what do you get over there? Lower limit is 0, upper limit is 2. 8 minus 2 is 6. 2 plus 1, 3. ln of 2 plus 1, 3, minus 1. Good. Lower limit minus 0 for x, 8 minus 0, 8. 0 plus 1 is 1. ln of 1 is, what is ln of 1? 0. So that would become 0, and I'll have a minus 1. So all of that is for the first integral after we evaluated lower and upper limit. And then I have the VDU part, which is giving me this. Minus times minus plus. X plus 1 times ln of x plus 1 dx. Good. We want to find the answer. This part is easy. Agreed. Just number. Yes, no, maybe. When you start writing, I'll give you a minute.
So minus one still part of it.
There is process and there is wisdom. The first part gives you a number, great. If you look at this part, I end up having an algebraic term times a logarithmic term. Agreed? Yes, no? Same thing I had up here. So when I go and take the integral again, I'm going to have an algebraic term and a logarithmic term. Yes? No? Okay. So one more step this way will give me an integral with algebraic terms and logarithmic terms. Good? So I would end up writing a lot of stuff, which I don't want to do. Good? This is going to expand really fast. So, wisdom comes with practice. The more you practice, the better it will be. Encounter a scenario like this, even though U is becoming 0 eventually, V keeps building up, correct? And building up in a way that is not conducive toward a solution. So each time you integrate ln of x, you're going to get x ln of x minus 1. So this is going to get lengthier and lengthier. This is where you stop integration by parts and go for numerical integration. Good? Or find a different technique. A problem like this, I don't want you to keep on doing it over and over and over again, because it will never end. This particular problem, it is going to end a complex integral. Imagine applying this over there into that. It will take forever. Agreed. So, concept of integration by parts. A few things to remember. I'm going to do an easy problem in a second. 1, isolate. 2, you've got to have 2 parts. The U part must go to 0, successive differentiation. The V part, successive integration. Good? If it doesn't happen, then we have a problem. Good? Yes, no, maybe. Okay. So, in this problem, I'm going to give up. And if you ask me, how do I find a solution for this in real life? The answer is to use a computer algebra system or numerical integration. Unless you get into mathematics, you wouldn't know what that is. Good? But is it doable? Absolutely. Good? So know when to stop. If U doesn't disappear to 0, you stop or you pick the wrong U. V must simplify, and if it's not simplifying, you stop. Otherwise, you're just going to keep on going in circles. Good? Okay, now to an easy problem. Got it.
I don't know if you already went over this, but what happens to the 2 pi in the end? You just.
It's still there, I just didn't write it, the 2 pi is still there, I just focused on that. Good,
How did you go from the upper bound or the bounds for the second integration? From 4
this
to-
one,
Yeah, how'd you go from 4 and 2 to 2 and 0 on the other
the
side?
first piece is 0 to 2. That is all I tried to do, I didn't even get to that.
Okay, so this half is.
Yeah, this half is for this. That's what I was trying to say. If just this part is giving me all this pain, imagine trying to evaluate the entire integral. If I put a problem like this on the exam for method of cylindrical shells, I will stop right here. I'll say set up the integral, call it quits. I'm not going to ask you for an answer.
So, are you supposed to write the integral of 0 to 2 before that u turns v?
It
No, before.
or that.
Yeah.
Yes.
because
So this
You
gets
just didn't write it?
evaluated.
You just didn't write 0 to
I
2.
just didn't write it, but it gets evaluated. I'll do it with a simpler problem. Do we get the nitty-gritty details of integration by parts? Okay, now for an easy problem, isolate, u must go to 0, dv, you are going to integrate in such a way things simplify and they don't get overcomplicated. Good? Okay. Erase. Leave isolate as is. And here is an example, easy one. Integral, x times, I love sin, so sin x. 0 to pi over 2. And it's a. It's okay. I don't believe in heaven or hell. There's no such thing. That's my opinion. Okay. Do we have 2 parts? 2 functions? Yes or no?
Yes, you do.
Okay, Caleb, what are the 2 functions?
X, sin X, or Y.
One is x, the other is sin x, right? Okay, so there are 2 functions multiplied together. Naturally, you are about to ask, well, should I do u substitution? Well, what is the key rule about u substitution? If you pick u, du has to be in the integral. Well, let's start with x. If u is x, du over dx is 1. Do I get sin x? No, can't do. If I pick u as sin x, du over dx is cosine x. Do you see cosine x? No. So u substitution is not going to work. Good? Why am I starting with u substitution every single problem? That's what you're supposed to do. You have to pick the easiest technique, and that comes with practice. We've done u substitution, so I'm checking for u substitution. Not going to work, so I'm going to move on to integration by parts. 2 parts, you tell me which part should be u and which part should be dv. Model number 2.
X is u and then sin x is v.
Michael number 2 tells me u must be x, dv must be the remaining part, sin x times dx. Does the differential dx show up in dv? It has to, even if you forget, write that in there. Okay, I took part of the integral, put it up there. Michael, number 2, why did you pick that way?
Because x is algebraic and sin of x is
X is algebraic and sine X trigonometry. Let's say you forgot isolate altogether, can I erase this? And you did this. With practice, you won't be making these mistakes, but until then, I'm going to erase this part. So hypothetically, let's say you pick u to be sine x and dv to be x dx. Good. Ask yourself, I am going to successively differentiate. First time you differentiate, what do you get? Cosine x. Second time you differentiate, negative sine x. Third time you differentiate, negative cosine x. Okay, not a good idea. Now over here, we have to successively integrate. First time you integrate, x squared over 2. Second time you integrate, three over 3, x cubed over 6. Yes, is that becoming 0? No, means abort mission. You picked the wrong year. Good, it has to become 0. Is that getting simplified or complicated? It is getting complicated. Abort mission, something's wrong. Okay, this is in alignment with isolate, so works. Now we've got to find the derivative. Du over dx is, what is the derivative of x? 1, which would imply du is just dx. Good. The other part, v, you have to integrate. What is the integral of sine x? Negative cosine x. We are integrating, not differentiating. So I've got u, I've got du, I have dv, I have v. I'm going to use the formula uv minus integral v du. Good. U times v, x times negative cosine x. That is the first term, u, v. Limit 0 to pi over 2. You've got to apply the limit for uv part of the solution, minus integral v. Bad mark. Dx should be there. Integrating, dx should go away. Dx is going to come from here. V du. uv minus v du. Does that match up to the formula that I wrote? uv minus integral v du. Good. Okay. Time to plug in limit. If I plug in pi over 2, the first integral is going to go away because it will be 0. Lower limit, 0. Gone. So all I'm left with is this. Agreed? Yes or no? So that will go away when I apply the limits. Negative times negative is positive. 0 to pi over 2. Cosine x dx, first part is 0. What is the integral of cosine x? Is a question, integral of cosine x? Sine x,
What did I say, negative cosine?
negative, and there is a negative outside, so minus 50. Integral would be sine x, lower limit, upper limit, What is the answer? Sine I over 2, it is 1. So the formula uv minus integral v du is key. Anytime you say integration by parts, that must come to your mind. This is a trick that you can do. I'm not sure if your book has it. If you Google, you might find it. This is called the tabular method of integration by parts. This also depends on choosing u and v appropriately, or u and dv appropriately. If you don't, you're not going to get the correct answer. The remark that I wrote, u must go to 0 as you successively differentiate. The dv must simplify, comes from the tabular method. Good? So you write out u and dv. Good. Step 1, u is x, dv sine x. Good. As you go down, you are going to take the derivative. X, take the derivative, what do we get? 1, take the derivative of 1. What? Easy. Derivative of 1. 0, okay. We are integrating, so integral of sine x, negative cosine x, integral of cosine x. There's no outside, so I'm going to put negative sine x. What is the derivative of 0? 0. And derivative, integral of negative sine x. Cosine x. Good. Okay, I'm going to stop right there. The moment you hit 0, you can go one extra step, and after that, it's unnecessary. Okay, how does this work? So think of running over a cliff and jumping, diagonally. So run, jump, run, jump, run, jump. Good. I use the same when I teach linear algebra. At that time, it's run, jump straight down. Here, run, jump diagonal.
We put that in a slide or something. Jump back.
How do you can't slide in air.
Sorry.
You can't slide, as you're jumping. How could you slide? You're just jumping at it. No, this is going in a different direction. Let's not get into it. Talk to me after class. So, are you with me? No. Alternating signs, plus, minus, plus. If it's another step, minus, and you keep on going. Good. From tabular method, all we are going to do, the running part, sliding part, jumping diagonally part, x plus sign, think of +1, x times positive sign times negative cosine x. So the first term, negative x cosine x. Good. Off to the next step. 1 times negative 1 times negative sine x, positive sine x. Good. 0 times positive sine, positive 1, still 0, times cosine x, still 0, 0. Past that point, you're just adding zeros, so don't worry about it. Good. This answer right here is what we had up there. Negative x cosine x, that is the first term. Sin x is the second term, right? I asked you which one's easier. Okay. Obviously the second one, but do keep in mind, the second one might fail you too, sometimes. So doesn't matter which approach you pick. The reason why I started by saying u must vanish as you take the derivative, v must get simplified as you successively integrate is because of this method. Good. So if you plug in 0 and pi over 2, you are going to get 1. Yes, no, maybe?
So it's basically just doing the tabular method and then taking the upper and lower. limits
Yep.
And just following through.
That's it. So if you plug in upper lower limits, you're going back to the step. Right? But perhaps I should write that. So once we do the tabular method, I'm just going to apply lower and upper limits. That term is going to go away, and I'll have sine pi over 2, which is 1.
Is there a reason why you did an extra step after you got to 0?
Here,
Yeah.
I just wanted to demonstrate that past this point, it's going to be 0. But would I even go forward? No. The moment I get 0, I will stop. Good. Easy one for you to try. Let's keep it simple for today. So you should know when to give up when it comes to integration by parts. So, I said let's keep it simple, so let's just do x. X times e raised x dx. You pick the appropriate u and v and tell me what the answer is. I am pretty sure that you all went for tabular method. Correct. Majority of you probably went for it. I like his better. There is a reason why, and we will test that next time. What should u be? Is it x or is it e raised x dx? X, violate. So x here, e raised x dx. What is the derivative of du? Sorry, u. 1, which would imply du is simply dx. If you integrate e raised x, what do you get, Carter?
Either
E raised x. Formula uv minus integral v du. U times v is x times e raised x. Evaluating the limits between 0 and 1 minus integral 0 to 1 v du e raised x times dx. Well, upper limit, you get 1 times e raised 1, which is e. Lower limit, doesn't matter, it is going to become 0, minus here, integral of e raised x is still e raised x. Plug in upper limit, lower limit. So e minus upper limit e raised 1, which is e. Lower limit minus e raised 0, 1. Distribute the negative, those two will go away. and you will end up getting +1 as the answer. Yes? If you want to do tabular method, that is fine also. I'm redrawing this so that you can understand. So x, erase x, successive differentiation, x becomes 1, derivative of 1 is 0. I'm going to stop right there. Integral of erase x, erase x, erase x, one more time, erase x. Good. Run, jump, positive, negative. Good. X times +1 times erase x. You will get x erase x. 1 times -1, -1 times erase x, negative erase x. If you look at this step, this is no different from that. Good. So it is a matter of choice, but do keep in mind sometimes that also fail you. There is a reason why I go with this approach. I will start with that on Monday.